Assalamualaikum warahmatullahi wabarakatuh. We are from Group 3, Section 11. We will present about the concrete material with agricultural waste. Ismul Atika binti Faiz Ukama, DF 2098. Next, Siti Atika binti Muhammad Zaid, DF 20000099. Third, Aini Najla binti Ahmad Tasbih, DF 200129. Next, Nurmizatu Anissa Johalmi, DF 20000109. Last one, Sisti Mastura binti Rahman, DF 200118. Alright. It is commonly recognized that the use of materials in construction has a significant environmental impact owing to the effect of embodied energy and other environmental implications, as well as disposal issues with particular materials. The goal of this review study is to discuss the function of various agricultural waste utilized in the building sector, such as varnish ash, coconut shell, and wood straw. Its concrete as a binding medium is one of the most popular and frequently utilized civil engineering method for maintaining the world's rapidly rising population and rapid urban growth. Particularly in a developing nations, environmental sustainability has emerged as a critical issue in terms of natural resources and waste. Environmental sustainability has emerged as a critical issue in terms of natural resources and waste. The building industry is the largest user of natural materials, and in addition, a large amount of wastes result from the demolition of constructions. Thus, construction can help to improve the economic viability of agriculture through adding value to existing crops using waste agriculture materials or even developing new crops.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Atika binti Muhammad Zain, and I would like to present about our first material, which is wheat straw ash. Cow 2017 said that wheat straw are organic waste that is not easy to decompose, and then the easy way to decompose this waste is by burn it. And then Memon 2021 state that the several researchers have been undertaken to save natural fund aggregate by replacing it with agricultural waste ash like wheat straw ash. And then Binichi 2008 said that increasing the addition of agriculture ash such as concave ash, wheat straw ash, it can increase 2 until 6% weight of fine aggregate, and then it can increase the quality of the concrete. We move to alternative method. So this method is from Binichi 2008. So the material that they use to mixing this concrete design is ordinary Portland cement, aggregate with size 19 mm, water, and with straw ash with 0, 5, 10, 15, and 20% of sand volume. So the table show that the quantity of the mixed design for this concrete. And then the concrete composition will be evaluated for various concrete qualities such as a SAM test, fresh density test, shrinkage response, compressive strength, and acid response test. We move to solution. So for solution is all about the result that we choose from the journal. And then for the SLAM test, has been shown in the histogram graph. The SLAM value is increased as the amount of WSA in concrete increase. This is due to the effect of larger quantity of water that retain in the porous and tabular shape of wheat straw ash. And then for concrete fresh density, the decrease in density of wheat straw ash in compared concrete is due to the effect of porous nature and lower density of wheat straw ash. For shrinkage response, we can show on the graph all the wheat straw ash concrete mix show a decreased shrinkage response. This is because of the water absorbed inside the WSA act as a water reservoir, and then it preventing self-desiccation of the cement paste by meeting the need of water during cement hydration. For compressive strength, the compressive strength of mix increase up to 10% with straw ash inclusion, then drop with more with straw ash incorporation. while the result remained higher than control concrete. For the last testing result, which is acid response test, with a higher replacement percentage of sulfuric and hydrochloric acid, weight loss is decreased. As I previously stated, the water absorption of concrete at any given age decreased as the amount of the fine aggregate replaced with the WSA increased.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aminazila binti Ahmad Tazri. I will present for the second material, which is coconut shell. Coconut shell, it turns out, had a significant role in decreasing plastic shrinkage cracks in the concrete, as evidenced by the summary of cracks and the diffusion test. The concrete made with coconut shell aggregates had a greater pulse velocity and a higher strength, and it was determined to be a long-lasting concrete. The structural behavior of CSA was found to be similar to that of other lightweight concretes. Under design notes, the diffusion was found to be acceptable. The durability attributes were equivalent to conventional concrete, and that mineral mixtures improved the characteristic. With the rise in replacement ratio, thermal conductivity dropped and specific heat capacity increased. The density of concrete decreased as the friction of coarse material replaced with coconut shell increased. Materials for this method are cement, water, aggregates, and coconut shell, which are the coconut shell are varying in percentages like 0%, 5%, 10%, 50%, 20%, 25%, and 30%. So the materials are all mixed. Then dry mixing of all components takes 2 to 3 minutes, and then followed by wet mixing for 3 to 4 minutes when water is added. Rheological characteristics such as compaction factor and slump tests are used to examine the fresh qualities after mixing. For results, there are two sections, which are rheological properties and compressive strength. For rheological properties, there are two testing that have been done, which are slump test and compaction test. For slump test, as the graph shown, the workability of concrete reduces as the amount of coconut shell used by coarse aggregate increases. For compaction test, as the friction of coconut shell replaced by coarse aggregate increases, the compaction factor decreases, resulting in an improvement in concrete workability as compared to the reference mixing as zero as shown in the figure. For compressive strength, 100 mm cube examples were utilized for each of the mixtures studied. According to the mix design, the mixes up to 20% coconut shell as a replacement for coarse aggregate displayed appropriate concrete.
Assalamualaikum, I'm Normizatul Anisa and I will explain the third material, which is bagasse ash. Bagasse is the remaining waste in sugar industry and currently utilized mostly as a fuel to meet its own energy need. Therefore, the concern of the study is how to handle the sugarcane bagasse ash SCBA, which is the byproduct from the burning of this bagasse. There are three literature reviews that we focus in the study, which are from JAMSA, Terima, and Amin. Basically, all these journals suggest SCBA as a cement substitute to improve the quality and lower the cost of construction materials in concrete while also reducing pollution. For JAMSA, the SCBA proportion being used is at the range of 5% to 30% at the interval of 5%. Slump contests and compressive strength were undertaken at the edges of 3, 7, and 28 stage. For Terima, there are 5 different concrete made with SCBA replacement at the range of 0% to 20% at the interval of 5%. The sand we used was regular river sand. The preparations of SCBA was taken fresh from the furnace. For Amin, he used high-strength Portland cement and crushed dolomite aggregate. The sample were taken at random from the sugar mills yard and transported to the lab in plastic bag. It was then burned at 350 Celsius for 1 hour to reduce the carbon content to 4.5%. Ash was powdered after cooling before being used. The proportion of the SCBA is at the range of 5% to 30% at the interval of 5%. The concrete was mixed for 5 minutes in a laboratory mixer, then 100 mm cube were cased for compressive strength testing, and cylinder measuring 150 mm times 300 mm were cased to determine tensile strength. For JAMSA, the compressive strength shows that with the increasing ratio of SBA up to 20%, concrete compressive strength rose with partial substitutions of sand by SBA. For tensile strength, the split tensile strength of concrete increased initially as the fraction of cement replaced with SBA grows, peaks at 20% and then declined. For flexural strength, found that 20% substitutions of cement resulted in significant improvement in flexural strength. For Terima, basically the compressive, tensile, and flexural strength shows that the mechanical properties were increased proportionally to the age of concrete. However, as you can see, for compressive strength, the optimal value for the SBA percentage being used is at 10%, and for tensile strength at 10%, same goes to flexural strength. For Amin, the compressive strength increased with the increasing bagasse ash up to 10% and then at 20%. For tensile strength, splitting tensile strength values increase in specimen having up to 20% bagasse ash addition. However, the value drops at 25% and 30%. Obviously, a maximum ash content of 20% is regarded ideal.
Okay, I will continue with the recommendation and conclusion. The recommendation. Concrete is the important construction materials and the quantities concrete material was used to develop the infrastructure construction. Okay, in this study, we recommend coconut shell. Okay, coconut shell as a replacement for coarse aggregate. It gives higher value of corrosive strength and it can make as a lightweight concrete. Not only that, it also having good interlocking same to the conventional of concrete. The second is sugarcane. Sugarcane as a replacement for cement. Okay, we know cement is a major material in concrete mixing and it also having good environmental function. So, with choosing the suitable percentage of mixing, it will give higher value of strength. Okay, with good design load, it can ensure the durability of concrete. In the conclusion, agricultural waste is the unused material that produced from the agricultural operation. So, the researchers was do the innovation for that waste to use in concrete mixtures. All the waste mentioned having a good result in their own performance. So, it was proof that the performing of the agricultural waste can give more benefits to the concrete materials. The innovation of the waste need to widely conduct and then we can also compare the data with the other researchers. The more comparison data, the more accuracy we can get. That's all from us. Thank you.